Hi, today we are going to be looking at multiplying and dividing fractions. Today we'll have 4 cases we're going to be investigating. In case 1, we are multiplying proper or improper fractions. Our first step is we are going to multiply the numerators and we're going to multiply the denominators. So we have 3 times 4 divided by 5 times 7. We end up getting 12 over 35. When we are looking at fractions, we try to look to simplify, which means we are trying to reduce the fraction to a smaller representation, but not changing the fraction so that it's not equivalent. So in order to do this, we need to look at what are the factors of 12 and 35. If we have a factor that is the same for 12 and 35, then that means we can divide the numerator and the denominator by that factor in order to reduce. So as we list them, we have 1, 2, 3, 4, 6, and 12. All of these numbers are factors of 12. Let's investigate 35. Factors of 35 are 1, 5, 7, and 35. As we observe, we notice that there are no factors or common factors between the two. So therefore, our final answer is 12 over 35. Case number 2. Here we're multiplying mixed fractions. Our first step is we're going to convert each fraction into improper form. And we can do this. If we have 2.5, we multiply the denominator by this whole number, 2 times 2. And you add the numerator to it, which means that we have 4 plus 1, and that's 5. So our answer will be 5 over 2. If we look at the second fraction, we have 4 1/3. Same steps, we need to multiply the denominator by the whole number, and we need to add the numerator to it. And 3 times 4 is 12, plus 1 is 13. Now our second step, we need to multiply the two fractions. So let's rewrite them. We have 5 over 2 times 13 over 3. Five times 13 over 2 times 3. 5 times 13 is 65. 2 times 3 is 6. And let's look to convert to a mixed. Convert to mixed. And remember, when we convert it to a mixed fraction, we ask ourselves, how many times does 6 fit into 65? And I know that 6 times 10 is 60. And if we do 6 times 11, that'll be 66, Whoa, hold up. Let's go back. Therefore, we know that we have 10 times, and 65 minus 60 is 5. So we have 5 remaining out of 6. And there is our conversion to mixed form. That is it for case 2. Let's move into dividing now. When we divide fractions, our first step should always be to look to flip the second fraction upside down. This seems a bit odd, so let's look to an example to understand why. I'm going to take the example of 2 divided by 2. We know the answer is 1. We can rewrite these numbers as fractions. We rewrite them as 2 over 1. If we flip the second fraction, it'll become 2 over 1 times flipped it. Now the numerator is on the denominator and vice versa. We have 1 over 2. If you'll notice, we have a 2 on top, 2 on the bottom, and 2 divided by 2 is 1. So we're left with 1 over 1, which is the same as our initial answer. So let's follow step 1. We have 4 over 5, and if we flip 1 over 3, it becomes 3 over 1. And our second step states we need to multiply. And as we did in case 1 and 2, we multiply the numerators and we multiply the denominators. 3 times 4 is 12. 5 times 1 is 5. Let's see if we can convert this to a mixed fraction. And you ask yourselves, how many times does 5 fit into 12? Well, the answer is 2. 5 times 2 is 10. So it's 2 times. And we look to have a remainder of 2. We write 2 over 5. And there's our final answer. So that is it for case 3. Next, we'll look at case number 4. And case 4 is when we are going to divide mixed fractions. In the Swedish curriculum, this is an A-level goal. That's why I wrote A-level. Let's look at our first step. The first step says we need to convert each fraction to improper form. And let's do that. We have 2 and 1 over 6. So you multiply what is 6 times 2, and you add it to the numerator. We add 1, and this is over 6. 6 times 2 is 12, plus 1 is 13 over 6. Look at the other fraction. We have 4 and a third. we have 3 times 4 plus 1, which is 13 over 3. So let's rewrite this as, this is the same as 13 over 6 divided by 13 over 3. Step 1 is done. Step 2 says we're going to flip the second fraction and multiply. That means we're going to flip this fraction. So now we'll have 3 over 13, and we're going to multiply. You should notice that we have 13 on the numerator and 13 on the denominator. And this strategy, we can see that we can cross reduce, which means we're basically simplifying our answer before we do any sort of multiplication. I know 13 divided by 13 is 1. And we're just left with 3 over 6. And 3 over 6 can be reduced. I know if I divide this by 3 and this by 3, this is the same as 1 over 2. So our final answer is 1 over 2. I've thrown a challenge case in here as well. It's when we're multiplying and dividing algebraic fractions. The last question, we found that we can cross reduce, and it made our lives quite easy. In cross reducing, this means you need to look to simplify the numbers and or variables before multiplying the numerators. So let's look at the first question. You have 2x over 3y times 9y over 2x. As you look at this question, you should notice that 2x divided by 2x, that equals 1. So we're left with 9y over 3y. And 9 divided by 3 is 3. And y divided by y is 1. So our answer is 3. In question B, becomes a little more complex. Remember, from case number 3, when we are dividing fractions, we need to flip the second fraction. So let's do this. We have 4x over 5y squared, and we multiply after we flip 4x. At this point, you should notice that you have a 4x here and a 4x here. When we cross reduce, 4x divided by 4x is 1. Now you're left with 5y divided by 5y squared. And 5y squared can be written again as 5y times y. And we have 5y divided by 5y. That's 1. So our answer we're left with is 1 over y. Thanks for tuning in today. I hope this video was helpful. Please don't forget to subscribe and like this video.